Observe here, guys. In last class, we have studied so many examples of illustrations of Newton's third law of motion, like from the beginning of how do we walk, why it is difficult to walk on the slippery roads or ice, how we are swimming, and as well as why the gun recoils, same way how the jet aeroplanes and rockets are flying, and same way how the boat, in the case of boat and as well as ship, how it is happening when we jump out from the ship, why the boat is going backward or ship is going backward, and these are all the things we discussed in the last class, including the case of hose pipe, that is what fire engine fireman, why he need to hold the hose pipe very tightly when the water is coming very forcefully. Is it yes or no? Yes, ready? Now, let us come to the last illustration of Newton's third law of motion. That is what in the case of horse pulling a cart. What is that? Horse pulling a cart. Now, if you notice it very carefully, can you see this picture, everybody? Kaushik, Arun, Kailash? Now, basically, some force is acting between these tires and the ground, which you studied in the class 8. Anybody can tell? Some force is acting, which is between this tire and the ground, which is acting always opposite to the direction of motion. What is that force? We used to call it friction, or we can say frictional force. Is it yes or no? Friction, or we can say frictional force. Now, when the horse need to pull this body heavy load with this bullock forward, then it needs to apply more force than this frictional force or less force than this frictional force. That is what my question.
More force.
Understand? If it is heavy loaded, or if the horse is unable to exert more force, that is which force we can say? Forward force. What we used to call? Forward force. Understanding? If the now horse is pulling or pushing, it is trying to pulling the cart. Is it yes or no? So horse pulling the cart, if you notice it here, in the case of this one, so horse pulling a cart in a forward direction, when it will exert more force than what? More force than frictional force, or this is what friction, then only the cart will move forward. Is it yes or no, guys? Yes, please respond. Now, if you notice it here, if horse is trying to pull it backward, observe the legs carefully. It is trying to do something. It is applying the action on ground in which direction? Action on ground in which direction? In the backward direction. See, with his legs, it is trying to push the ground in the backward direction. Is it yes or no, guys? And also see, when he is trying to push the cart, pulling the cart, its legs are, his head is coming forward. All the animals like that only. Have you noticed it? When even the bulls, when they're trying to pull the bull cart, their head will go front and they'll try to pull it very forcefully. Is it yes or no, guys? Yes, please respond. Here, so what will happen? For example, the cart exert an equal and opposite force on the horse, then you can see it seems to be force is being equal, so that there is no motion in the cart. Is it yes or no, guys? For example, horse is applying some force on this cart, and this cart is also applying some force on the horse. Now both the forces are equal. Is it possible to pull the cart in the forward direction? Is it possible to pull the cart in the forward direction? The cart not move. Is it yes or no? Because both the forces are equal and opposite. Is it possible to pull the cart forward?
No, sir.
No. When the cart will move forward, anybody can tell? When the cart will move forward, if the horse will apply, if the horse will apply greater force than the force exerted by this cart, then only the cart will move forward. Will you accept it or not? Please respond. Yes. So that is why you can see, all of you remember, only the force on the cart will determine whether the cart will move or not. So the force exerted by the cart on the horse affect the heart alone. Understanding? Affect the horse alone. So now that is why you can see, if the horse is exerting equal force, like what cart is exerting the force on this horse, the cart does not move forward at all. So horse need to exert more force or less force? More force or less force? more
force.
force, understanding, more force than the cart, so that it is always need to bend his knees. Have you noticed it? It is need to bend his knees forward and need to pull, understanding, pull the cart more forcefully. That is why the horse neck also will go what? Horse neck also will go forward. Understand, it will bend. So that is why you can see, if the horse is able to apply the enough force to overcome the frictional force which is present, then the cart will move forward direction. So that is why to exert more force than this frictional force, always a horse will bend forward and push the ground with his feet. So that is why when the forward reaction of the backward push of the horse is greater than the opposing frictional forces of the wheels, so that the cart will come forward or not? So that the cart will come forward or not? Yes or no?
Yes,
So at a time, horse is doing two actions. Metakshari, can you say that what is the two actions done by the horse here? One is with the head, it is trying to move forward, and with the legs, it is trying to push the ground what? It is trying to push the
Backward.
ground backward direction. So at a time, this is the forward action, and as well as the backward action. It will be exerting more force than which force? More force than frictional force of this cart, so that the cart will start moving forward direction. Do you understand, everybody? So this is what we can say. Understand, when the two bodies are in direct contact with each other, remember always, it is not always necessary to two bodies can exert force on one another only when they are in contact. If they are not in contact also, they will exert the force, equal and opposite force always. That is what we already studied. That is in the case of what? Magnets and all. Is it yes or no, guys? Yes, please.
Yes, sir.
Yes. So now observe very carefully also that if you want to apply the Newton's third law of motion, it is not necessary that bodies need to be contact. If they are not contact also, they will exert equal and opposite forces. Now, if let it be forget about it. Now come to this case. Now if the cart want to move forward, horse need to do two actions at a time. What is the two actions, everybody? What is the two actions? It needs to
Movement of head and
pull his head forward, and it needs to push the ground with his feet backward direction. So at a time, this forward action of head and backward action of foot, it is trying to push the ground in the backward direction. So that what will happen, guys? If we are exerting more force, horse will exert more force than the frictional force exerted by the cart, so that the cart will move forward or not? Yes or no? That is what you might notice it. A fast runner, even in humans, when we are running very fastly, then automatically our head will move forward always, and our legs more forcefully will try to push the ground backward direction. Is it yes or no? Is it yes or no, everybody?
yes, sir.
Yes, so that is what. So even you can see the bulls which are moving very faster, their head is always bending forward direction. Why they are bending forward direction head? Because to exert more force. You understanding? To exert more forward force. When it is bending forward the head, then with the legs, it will exert huge amount of force on the ground and will push the ground very forcefully. So that what is happening? The cart or bull cart or whatever it is, it will move forward direction. Is it okay, guys? Yes, please.
Yes, sir.
That is what you have to remember. So here also, the force exerted by horse on the cart is called as action, and the force exerted by cart on the horse we used to call as what? Reaction. Understand?
Reaction.
What you have to remember. But when the action is equals to reaction, is it any motion in the cart? When the action is equals to reaction, no motion in the cart. Means cart is exerting some force on the horse is also exerting some force on the cart, then there is no motion. So that is why horse at a time doing forward and as well as backward action, so that it is exerting more force than the frictional force of this cart, so that the cart is moving forward. Is it okay, everyone? Yes, please.
Yes.
That is what. Akilan,
Yes, sir.
Reddy, what happened to Danishkar? He not yet joined. So that is what you have to remember. So this is all about what is illustrations of Newton's third law of motion. And also remember, we can make that in this all these examples you observe, the two interacting bodies are in direct contact with each other. Is it yes or no? Every example you can take, walking, from the walking time to pulling the cart by the horse, everywhere bodies are in contact or not? Yes, please respond. Bodies are in contact or not? So they all are in contact. But you remember, in some cases, it is not necessary that two bodies, understanding, need to be in contact to exert the force on one another. Okay. So in some cases, for example, if we'll take, even though they are not in contact with each other, they can exert force on each other. I understand everybody. So that is why the interaction can also take place even when the two bodies are in not in contact, but the force exerted by them is always existed equal and opposite reaction. So that is why you can say in all such cases, the force of action and reaction are equal. And what, guys? All the cases, force of action, if there is action, then equal and what? Equal and opposite reaction. You have to say equal and opposite reaction. That is what you have to use it word. So that is why. So what is the example of action and reaction which is exerting between two bodies but they are not in contact? Anybody? They are not in contact. Not in contact. Example, magnets. Understand? So magnets exert a force, understand, on iron, a piece of iron, and the force exerted on even when they are separated by a distance also. Do you notice it or not? So no need to bring the iron very close to the magnet. After coming to certain distance, directly iron will jump to the magnet. Do you feel it or not, Reddy? Akilan? Yes or no? So sometimes when you will bring it to the particular distance, these needles and all, automatically they will jump into the magnet and they will stick to the magnet. Is it yes or no? Yes, please. That is what. Okay. So the magnet exert a force on iron piece, and iron piece also exert an equal and opposite force on the magnet. And the interaction between, understanding, so this one, even though they are having certain distance, they will exert equal and opposite force and they will try to attract each other. That is the reason iron will be attracted by the magnet. Same way, 8th class, your teacher, physics teacher, maybe I have told you to do the activity called as rub the comb or pen in our dry hair and try to stick the small bit of papers. Do you remember? Electrostatic force. Remember, Mitakshri?
Yes, sir.
Everyone? That is what. So, yes. So a electrically charged comb and a piece of paper also takes place from a distance itself. So that is what, to prove that electrostatic force. Which force? Electrostatic force. Understanding? So static electricity we can say, electrostatic force we can say. So to prove that static electricity. So what we'll do, guys, we'll take one pen. You can take one pen or any kind of rod, something plastic rod, and we have to rub this one in where? Dry hair. Understand? So that it will get, it will be charged electrically. Now, if we'll bring the charged electrically, if we'll bring the piece of papers, these papers will be attracted or not? Please respond.
Yes, sir.
Yes. That is what will happen. So this is also example of what? This is also example of what? The force is acting between them without contact. What is that? Without contact each other. That is what you have to remember it. So that is what I can say. And finally, I want to say one thing. Always Newton's third law is exerting in pair or only single body. Single body or double pair, whatever it is. Maybe they are in contact each other or maybe they are not contact each other. But still always Newton's third law will act always in how many bodies, guys?
Two bodies.
Two bodies. That is what you have to remember. So the forces always occurs in pairs. Forces always occurs in what? pairs. Please, all of you remember that. Note it down. Newton's third law will says that, what is that, guys? Forces always occurs in pairs only. Please write it. Forces, according to the Newton's third law, forces always occurs in pairs. Is it okay, everyone? Danishkar, ready? Danishkar, be in time, boy. Don't be late. Okay, that is what everybody should remember it. Make it, everyone. Forces always occurs in what? Occurs in pairs. Okay, that is one. So this is all about Newton's law of motion. Remember, always Newton's third law of motion concerns these pair of forces only, pairs of forces. So single body does not exert both action and reaction. So action is done by one body and reaction is done by another body. Okay, action done by one body, and reaction is done by what? Another body. So always two pairs, that is what occurs in always pair of bodies. That is what Newton's third law cannot be existed in single body. Okay, everybody, are you clear? Gokul, Kaushik, that is what you
Yes,
have to understand. Now, if you'll understand this one, then we are going to study the very, very important concept, which is the most important one. That is only conservation of momentum. What is that, guys? Conservation of momentum. Okay, so very, very important. Conservation of momentum. Okay, we all people know already momentum. Anybody can tell what do you mean by momentum, please? We know already what is the meaning of momentum. Momentum is equals to what? Nobody is saying. Mass
into velocity, sir.
velocity. Is it okay?
Velocity.
Mass into velocity. So that is what we know, that momentum. Is it yes or no, guys? Yes, please respond.
Yes, sir.
Yeah,
yes,
listen
sir.
carefully. This derivation is very, very important. All should learn. Observe. Later, I will give time to note it down. So observe very carefully. So as we know from the second law of motion, we have studied that the moving bodies possess momentum. That is what, which is equals to the product of two quantities. What is that? The momentum of a body is the product of what? Mass and velocity. Yes or no, guys?
Velocity.
So every moving body, which body is having momentum? Which body is having momentum? Only the bodies which are in motion. Understanding? So body will possess the momentum only when it is in motion. If it is in rest, is it the body is having momentum? Anybody can answer? Akilan, Arun
No,
Kailash?
sir.
No, sir.
No. If the body is in rest, what will happen? If the body is in rest, then velocity is zero. So if velocity is zero, then momentum is equals to what? Momentum is equals to also zero. That is what. So
Zero.
which bodies will possess momentum? Only the bodies which are in motion. Understand?
Motion.
So that is what. So the body, the total momentum of a moving body, which is equals to product of mass and velocity. Product of mass and velocity. Are you understand, everyone? Now let us take momentum means we all people know mass into velocity. What is that? Mass into velocity. Now, in our today's class, we are going to study conservation of momentum. So, you all people are hearing even social studies and all. Conservation. What do you mean by conservation? Anybody? What do you mean by conservation? Yes, please. Respond.
Like we have to save that, sir.
Yes. That is what conservation means, like saving of energy or like usage of energy. Like we can save it very effectively. If we use it very effectively, then we can say it is called as conservation. Now, forget about that normal conservation. Then let us comes to here. What do you mean by this conservation of momentum means? Let us try to understand. So, for example, suppose a speeding truck or fast moving truck hits a stationary car. What will happen, guys? Respond, everyone. Suppose a truck is coming, which is very, very fastly moving, which is very, very, what is happening? Very, very fastly it is moving. Fast moving truck. Fast moving truck is coming and hitting a car which is at stationary, which is at what, Mitakshri? Which is at rest. Now, once the truck will come and will hit, ready, you tell me, will hit this car which is in rest. Now the car will start moving or not? Yes,
sir.
please respond. Car will start moving. Yes or no, Kaushik? Danishkar, if you involve only, you can understand this concept. Akilan, you also. Now, fast moving truck will come and will hit this car. Now the car will the car will start moving or not? Yes or no?
Yes, sir.
Now,
Yes, sir.
yes, please observe very carefully. Before hitting, the truck is having some mass. Is it yes or no? It is having some mass. Let me consider its velocity is initial velocity is V1. What is initial velocity? V1. Do you understand, everybody? So now before hitting, total momentum of the truck. Anybody can tell what is the total momentum? Mass into velocity V1. Is it yes or no? Yes, please respond. Now,
Yes, sir.
after hitting, the velocity of the truck will decrease or increases after hitting. After hitting, velocity of the truck will decreases. Velocity of truck decreases or increases? Please respond. Decreases. Car velocity. But car velocity, what will happen? Please respond. Car velocity
Increases.
Car velocity will increases. So, but if you'll notice it here, after hitting, if you'll add momentum of the truck plus momentum of the car, which is equals to total momentum before hitting whatever the momentum of the truck it is having, that is what it will be equal. Is it right or wrong? Is it right or wrong? Yes, please.
Yes, sir.
Yes, everybody. If you're not understanding, ask me. For example, see, before hitting, what is the momentum of the car? Before hitting, what is the momentum of the car? Zero. Why?
0.
Why momentum is zero before hitting car?
Because
Why? Because it is in what?
velocity is equal to
Velocity is
Rest.
zero, so that it is zero. Now, for example, I'm saying you value. Let me take before hitting, the total momentum of the truck is 100 kilogram meter per second. What is that, Mitakshri? 100 kilogram meter per second. Now, after hitting, the truck momentum came into 80 kilogram kilogram meter per second. Means in the sense of, what about the momentum gained by the car? What about the momentum gained by the car? 20 kilogram meter per second. Now, if we'll do the sum, before hitting, after hitting, both are equal or not? Both are equal or not?
Yes, sir.
Yes, please respond.
Yes, sir.
That is what? Do you understanding? So, when a speed truck or speeding truck hits a stationary car or the car which is in state of rest, so the car also start moving. So due to this collision, due to this hitting, somebody's momentum will decrease. Whose momentum is decreasing? Due to collision.
Truck momentum.
Is decreasing. Whose momentum? Anyone?
Truck.
Yes, please. Truck momentum is decreasing.
Yes, sir.
Collision. LLI. Please remember. Truck momentum is decreasing and somebody momentum is increasing. Whose momentum is increasing? Whose momentum is increasing?
Car momentum.
Car momentum is increases. So, and if you'll notice it has been found that increase in the momentum of car is equals to decrease in the momentum of truck. Is it right or wrong? I have taken values. Now, what is the momentum lost by the truck after collision? Anybody? What is the momentum of the truck after collision? Loss of momentum.
80.
20 kilogram meter per second. Now, after collision, what is the momentum gained by the car? What is the momentum gained by the car? What is the momentum gained by the car? Mitakshri?
20 kilometers.
20
kilogram meter per second. Now, so whatever the momentum lost by the truck, which is equals to the momentum gained by the car. Is it yes or no? Is it yes or no? Yes, please respond. So, that is why now we can say before collision, before collision, the momentum is equals to total collision after momentum. Remains same or not? Yes, please. After collision, yes or no? So before collision, what is the momentum of truck? And momentum of car, we have been taken example. Momentum of truck is 100 kilogram meter per second. Car is what? 0 kilogram
Zero.
meter per second. After collision, what is that? Truck is what? 80 kilogram meter per second. But car is what? 20 kilogram meter per second. So if we'll add both, before collision is equals to 100, after collision also is equals to what? After collision also is equals to what? 100 only. Yes or no?
100.
But that is what we can say. So there is no loss of momentum in the collision. Is it right or wrong? Is it right or wrong? Everybody?
Yes, sir.
Yes.
Or no? That is what. So during collision, truck momentum is decreasing, but whose momentum is increasing? Whose momentum is increasing? Car momentum is increasing. So whatever the momentum
Car moment.
lost by the truck, it is equals to the momentum gained by whom? Kaushik? The momentum gained by car. That is what you have to remember. So with this example, the momentum lost by the truck has been gained by the car. This is an illustration or example of law of conservation of momentum. This is the illustration of what? This is the illustration of law of conservation of momentum. What is Hari? Conservation of momentum. So please, all of you, try to
Moment.
conservation of momentum in our own words, try to make it so that I will continue the derivation and will prove that law of conservation of momentum is remains same. Understanding before collision and after collision, when the two bodies will interact, then we have to prove that the momentum before collision and after collision, it is remains same. Is it yes or no, guys? Yes, please. Everybody?
Yes, sir.
Yeah. So please all of you note it down. Whatever you understand till here, you write it. Keep heading conservation of momentum and try to understand this one so that we can proceed further. Everybody, is it understanding or not? Yes.
Yes, sir.
Yeah, you can note it down. So conservation of momentum. So from here I'm displaying. So whatever you understand, you note it down so that from here we'll proceed. Is it okay, Hari? Yes,
Yes,
please.
sir.
Mitakshi, I understand. Kaushik, Danishkar, any doubt anybody ask me? Okay, so please note it down, everyone. So example also you take example and you can prove that so that it will be easy for you. Please all of you keep it and make illustration of law of conservation of momentum and note down this one. Is it okay, everybody? Illustration of illustration of law of conservation of momentum. That is what. Do it fast. 2 minutes time. Completed, Hari? Everybody, please respond. Yeah. This is what we can make example of what? Illustration of Newton's, law of conservation of momentum. So now with the same illustration, we are going to prove mathematically with the derivation. Shall we prove?
Yes, sir.
Now, observe very carefully. What is Newton's third law, everyone? What is Newton's third law? Newton's third law.
Reactions incident reaction.
Newton's third law. Please respond, everyone. Newton's third law will says that if there is an action, then definitely equivalent there will be
Reaction.
every action there is an equal and opposite reaction. That is what the simplest definition of Newton's third law. Is it right or wrong?
Yes, sir.
Yes, sir.
Now, observe very carefully. For example, let me take Arun Kailash and Akilan both are fighting. Okay, Arun Kailash. This is what Arun Kailash and as well as this is Akilan. Now you tell me, if Arun Kailash will hit the Akilan, then who is going to affect? As we know that Arun Kailash will exert some force, Akilan also will exert the same equivalent force. Now, due to the Arun Kailash is exerting force, then who is affecting, guys? Who is affecting? Who is affecting?
Akilan.
Akilan is affecting.
Akilan.
Now, due to the Akilan exerting force, who is going to affect?
Arun.
Arun Kailash is affecting. That is what? Yes or no? So the force exerted by body one, due to the force exerted by body one, whose changes is happening? Who is getting affected? Who is getting affected? Body two is going to getting affected. Now, due to the force exerted by body two, who is going to affect? Body one is going to affect. Are you understand, everyone? Ready? Now, let us take, instead of persons, let me take now two cars. Let me take, this is the car one by somebody. Let me take, this is Danishkar car. And let me take, this car is by Mr. Kaushik. Is it okay, everyone? Now, if these both people, suppose Danishkar will go and will hit the Kaushik car. Now this is, let me imagine the force exerted by Danishkar is something. So now if Danishkar will hit the Kaushik car, whose acceleration or velocity, whose velocity or acceleration will changes? Whose velocity will changes? Kaushik velocity or acceleration will change. Yes or no? Now, if Kaushik will hit the Danishkar, then whose velocity will change?
Danishkar.
Danishkar velocity will change. That is what. So, if the body one will exert the force on body two, then we can observe the change in body one or body two. We can observe body two. Do you understand it? Now, if body two will exert force on body one, then we can see the change in what? We can see the change in body one. Are you understand or not? Please respond. Everybody.
Yes, sir.
Yes. Now, with the same Newton's third law, action and reaction, now we are going to prove according to the law of conservation of momentum. That is what we have been made one illustration of conservation of momentum. So according to the conservation of momentum, what we have been proved, guys? When the two bodies are acting upon each other, that is what? The total momentum remains constant or not? Remains constant or not? Total momentum before collision and after collision. Yes or no? Yes, that is what you have to remember. And no external force should be applied. That is also very important. So if the external force is applied, again it will be changing. So if no external force is acting, then always the total momentum remains constant or conserved of two bodies when they are acting upon one another. So that is only we used to call it as law of conservation of momentum. What we used to call? Law of conservation of momentum. So please all of you write law of conservation of momentum. Write the definition. If anybody not understand, ask me. Right. When two bodies act upon one another, when two bodies act upon one another, when two bodies act upon one another, the total momentum remains constant. Their total momentum